actually pointing to your fake object, and the EAX register is pointing to the handler table. So this is the table in stack that you control. So the idea of the exploit is very simple. You have an object handler table, which is actually your data on the stack, and the second entry is your delref handler, and you will put the delref handler to an exchange EAX ASP followed by a ret. You can search that by leaking the code segment of PHP remotely, so you can find it in memory. And because the handler table is pointed to by EAX, the exchange EAX ESP will change the stack pointer into your buffer. And from there you can just do the normal return-oriented programming. So this will look like this. You have a fake variable. In this case, it's an object. An object is identified by the 5, not the 6, but the 5. You put in a reference counter of -1, so that it will be freed. You put in the object handler's pointer will be a pointer to the stack location you just leaked and controlled. And the object handler can be anything. And what you do now is actually you do the same attack. Just this time you don't put in a string, a fake string. You use the same code just to put in the object. You just replace a string. And you can use the previously shown buffers for that. So what will happen now is at the end of the lifetime of this data structure you created with unserialized, this object will be destroyed. And the destructor will go to the object handler table, which is your stack buffer, and take the second entry, and we'll call it. You see, what we do is we just have an address there that points to exchange EAX ESP in the ret. So after the exchange EAX ESP, the stack pointer will be pointing to the first slot of your buffer. So what you do there is you put something more in there. You want to have a normal return-oriented programming thing here. So what you need to do now is adjust the stack pointer. And you just do that by returning into a pop and ret, which is very easy to find because it's all over the code in PHP. And after that, you will actually return to the code stored in the third slot, to the pointer stored in the third slot. And what we do is we will put in the address of send eval string. And this is just a normal return to libc way to call a function. And the send eval string gets 3 parameters. The first one is the actual PHP code that's supposed to be evaluated. The second one is a null pointer in this case, but because it should be the pointer pointing to the return value, but we don't need the return value, so you put in null. And yeah, the third one must be a pointer to readable memory, and we just put in the same pointer at the PHP info string. And again, this all is in a region of the stack you completely know everything about. You know the start address and the end address. So you know where the PHP info string is. And this all only because you have put it with the post data pather in the right spot. And the other thing is null bytes are no problem here because you can also put null bytes in the post request. Yeah, and for completeness, what you would do, put in the empty slot is the send bailout function, so that when you return from the executed PHP code, you would end up in send bailout. Anyway, this will crash because the address, this is in a place where I told you about the jump buff. The jump buff is a try-catch around all the execution of PHP. And when send bailout is called, it will use the jump buff to restore the stack value. And the problem here is that we are in a place of the stack that's already above the jump buff. So the jump off will not work. What will happen is the PHP code will be executed, and afterward it will crash. You can, of course, make the exploit more complicated to move it back downwards to the stack so that you don't overwrite the jump off with the PHP code. But this is the easiest way. Your code will be executed, but at the end it will crash. So that was a talk for now, so I will show you this simple demo. Actually, it's not so spectacular because so the first thing I show you is how I create these exploits for return-oriented, property-oriented programming. What I do is I will select the classes I wanted to use. I told you I use a send-log. I will create all the properties in the class with the same access restrictions as in the original class, because it must be of the same type, otherwise the unserialized will not override the right property. And then I will fill the constructor with something that fills the properties in a way that the exploit works. In this case, we remember the writers property, it has to be filled with a list of writers. And in this case, I just instant this class, which I defined here, and again I have put in the properties I want to have. In the constructor I create the specific objects or put in the right data, and again this is the send mail class doesn't need to be any property at all in this case because I just want a dummy class, so it's just an empty class. But the pvic view again defines a template and the smarty object. You see I create a smarty object, and in the template I put in the PHP code. And in this case, I was very lazy and put in the global variable PHP code in there. And yeah, the Smarty again will define the properties that are required to hit the code. And in the constructor, I will just create this special resource XPL and set the output filter to an empty array because I don't want an output filter right now. And here I just tell it the callback for the XPL resource is this object, which is pvic smarty, and the eval method. Yeah, and then I can define the PHP code I want. In this case, it's PHP info. And then I initiate the send log, put this all into an array. The first element will be the payload, and the second element will be just any value. I will serialize it, and then there's a little trick. I replace the serialized 999 with a 0. The idea here is I already have the 0, which is all my payload, and if I put another 0 in there, and this will get unserialized, then it will unserialize all the payload, and in the end it will put in the second element to the array, and the second element will also be key 0, so it will delete the first one. So I can ensure by manipulating the serialized data here that at the end of the unserialized, all the payload is destructed. And this is sometimes required because otherwise you might hit a fatal error or an exception, and this will end up in PHP terminating the request in an unsafe way, and so your destructor will never be called. So you have to ensure that the destructor is called in the end. Yeah, and then because I was very lazy this time, I just create a GET request. I echo its out. The host is t-test system. In this case, it's a cookie pvic auth, which is x equals the base 64 encoded exploit. Yeah, and actually, I ensured I patched my pvic. It's the latest version, but I patched it back to not have the blacklist. So all the exploit here will not tell you anything how to bypass the blacklist. You would have to do something to the serialized string after this here. So you have to like 3 or 4 modifications. When you do that, it will still work, but I don't show you. So you shouldn't see that clear. So what I do is I will show you when I just execute the exploit, it will create the header, which is all the serialized data. And yeah, and now I will just use netcat to pipe it to netcat. And you will see, oh, it executed. When you know PHP, you know that this looks very much, where's the mouse? It looks very much like a PHP info. And yeah, it is a PHP info. So we executed PHP info on the target system. And now I will just go back to the source code and change the code that is executed. Yeah. Again, I do the pvec exploit, which will be this time a different string. And now I pipe it again, and you see it executed system comment, uname A, and user bin ID. And by just changing this thing, you can execute anything you want. And of course, sometimes you maybe hit a web server with PHP safe mode and so on, or OpenBasedir. So you would just take the research I presented last year at Blackhat and create an anti-safe mode exploit, anti-OpenBasedir exploit, and just put it in the serialized data. Yeah, this was the return, the property-oriented programming thing. Now the second example, which will be the last one. Yes. It's a little Python script I wrote to exploit the unserialized use of the free bug. If you saw something about my syscan talk, you will see that I already posted something like this. But actually, if you compare it to the syscan talk, you will see that all the second half of the exploit, how to achieve code execution, is completely different from what I presented at syscan. Because people told me I let their brain explode with the other method. So this one was actually far more simple than the previous one. So okay, I execute this, and oh, actually it's really fast this time. When I tried this in my hotel room, it was endlessly slow. I don't know why. Same VMware. So what is happening here, it will first send some serialized data and determine the size of an integer and so on, and what PHP version it is. I didn't show this today because I don't have the time, but if you look at the syscan slides, you can see how this is possible. And then it will leak the address of the object handlers, will leak the object handlers, will optimize it to a better address and scan backward in memory. It will find the ELF header, retrieve all the headers, the program headers, the string table. Then it will look up some symbols, the executor globals, the send eval string. And then it searches the jump off inside the executor globals. It finds a stack address. And now this will take a while. It searches all the code segment for exchange EAX, ESP, followed by return. This takes a while. In my hotel room, it took like 2 minutes, but I hope it's faster now. Maybe it will never end. What should happen now is it first searches this gadget, and after